Please make sure you have your copy of the Experimental Design Second Assessment Review. This next assessment is going to be based on two experiments that we've done. One, the testing house paint for lead experiment, and the other, testing the detection limit of the lead test. So you can use both of those experiments to help you on the assessment, and you can use your review as well. So one of the problems that's going to be on the assessment asks about a result that I got a couple years ago. A student brought in a sample from the floor down in the ceramic studio, and it tested positive for lead. That means that when this sample was tested, there was a yellow cloudy reaction. There was also a yellow cloudy reaction in the standard, and the control had no reaction. And so we were able to rule out that the tube or the cup in the filter or the acid that was used in the experiment was the source of the positive result. That meant that whatever was put in the floor sample, whatever was part of that sample, had to contain whatever it was that made the reaction occur. And so I was concerned about that because I wouldn't want to think that we had lead dust blowing around in a classroom. So I repeated the experiment, and I included two metals that are known to be prevalent in clay, which is what we use in a ceramic studio. Clay comes from earth, and the two most abundant elements that are in earth are aluminum and iron. So I'm going to do a demonstration during the assessment where I'll show you the results from each one of these tests. But first you'll need to make predictions about what will happen, and then when I show you the results, be able to interpret what does that mean about any result that you get for the floor sample. Now, if we get a negative result for something, we want to know, is that because there really isn't any lead, or does that just mean that there's not enough to measure? And so that was the purpose for doing the detection limit experiment. If you don't have results for that experiment, you can watch how I'm going to do this one, and you can use that to write your own procedures, draw your own diagrams, show your own calculations. I'll show you how I set up and made the solutions, but I'm not going to show you the concentrations. You'll have to calculate those yourself. You can use these data in your on your assessment if you don't have any of your own. So here's what I did. I started with a solution that contains a known amount of lead, 6.25%. I chose that because it's pretty high, and it's much more than the amount of lead that would be permissible in any consumer product. And then I filled some little cups with water, which doesn't contain any lead. I filled each one of these cups with 6 milliliters of water. The last one I filled with 16 milliliters of water. I know that's different from the series, but I did that for a reason. And then the first cup I poured some of this 6.25 solution into, and then I took 4 milliliters from that and I mixed it with the water in the next cup. That means that less of the solution is the 6.25% solution. By mixing it up, I'm making it less concentrated. I'm trying to make it weaker. And then I continued adding 4 milliliters from each cup to the next one in the series and mixing them to make a less concentrated mixture. What I need to know is what's the concentration of each one of these cups. I know the first one is 6.25. What about the second one? So to calculate that, what you do is you take the concentration of the cup that you used to make the next one, and you take the amount that you added from one to the next, and you take the total of the volume. So if I add 4 milliliters to 6 milliliters of water, that makes a 10 milliliter total. 4 out of those 10 milliliters came from this solution. So 4/10 of this concentration is what's in the next cup. So cup number 2 here has a concentration of 2.5%. Compared to the one that I started with, this concentration is lower. What you would need to do then is calculate for cup number 3, if I use the same dilution factor, 4/10, what would that concentration be? And if I did the same thing all the way down, diluting by 4/10 each time, what would be the new concentration? Now the last one is not diluted by 4/10, it's diluted by 4/20. So you'll have to watch out when you do that calculation. So let's take a look and see what happens. I'm going to add the potassium chromate solution. We're looking for evidence that there's lead in the solution. The cloudy reaction tells us when there's lead. So the first one turns cloudy as expected because that's the highest level of lead. And then the next one turns cloudy. And that one's cloudy. And cloudy. 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 Okay, that one's cloudy too. Not quite as much. And let's try the last one. Okay, the last one, not cloudy. So up until I got to here, the reactions were all strongly cloudy. This one, there's cloudiness. I can definitely see it, but it's not as cloudy. And then the last one, not so cloudy. Maybe just a little hint of cloudiness there. So the amount of lead is decreasing, and as a result, the ability to detect the lead is decreasing. We need to know what's the smallest amount of lead that you can detect, because we want to know if that is going to enable us to find out if there's more lead than is allowed by law. So for example, in house paint, we should be able to detect as much as 0.06%, a small amount. Children's toys, even less. You would want to know if I did the test like we did here, and I tested some house paint or children's paint from toys, if I got a negative result, does that mean that there's no lead, or is there too much lead to be safe and I just can't detect it? There are some other problems that are on the review which we'll look at together after you've had some time to try them yourself.